Okay, so unlike derivatives, we won't always be able to find exact values for integrals, definite integrals. And so we learned one way how to approximate them. We learned about Riemann sums. And those use rectangles to approximate. Well, we can do better than rectangles. One thing that we could do is we could use trapezoids. So the trapezoid rule is the exact same idea as Riemann sums, except we're using trapezoids. And we kind of have a formula for it right here. So we're going to have delta x over 2, which delta x is those widths. We thought of them as the base of our rectangle. So to do that, you do b minus a over n. Then you're going to take each of the kind of endpoints of what were the bases of your rectangles, and you're going to plug them into your function. And you're just going to take what you got plugged into your function plus 2 times the second one, plus 2 times the third, all the way up, and then 2 times the second to last one, but then just plus the last one when you plug it in. Okay, so this says use the trapezoidal rule with n equals 4 to approximate the integral from negative 2 to 6 of x squared e to the x. So I like to draw kind of what our base would look like. So we'd go negative 2 to 6. And our n is equal to 4. So if we do delta x equals 6 minus negative 2 over 4, we get 8 over 4, which is 2. So each of these are going to have a width of 2. So that would go 0, 2, 4, 6. So each of these, think of this is x0, x1, x2, x3, x4. And so we're going to plug each of those into the function, into our f of x here. And we'll multiply the y values for the middle ones by 2. So just multiply by 2. But the rest of them, the first one and the last one, we just plug it in. So here, our t, we'd have delta x2 over 2 times, first we plug in x0 into our function. So it'd be negative 2 squared e to the negative 2 plus, now each of them we're going to plug in, for the middle 3 we're going to put a 2 out in front. So we plug in 0 plus 2 times plugging in the next one, which is 2, plus 2 times plugging in the 4. And then the last one, we don't multiply by 2. So 6 squared e to the 6th. Okay, so we can plug that into our calculator. Now 2 over 2 is just 1. So we can do negative 2 squared e to the negative 2 plus 2 times 0 squared. This is just going to give us 0. Okay, so we had 0 squared e to the 0 plus 2 times 2 squared e squared plus 2 times 4 squared e to the 4th, and then plus 6 squared e to the 6th. Okay, and we get that our approximation is 16,330.23. So that would be an approximation for this integral that otherwise we don't know how to solve.